add acid and bases together to get a neutralization reaction. We've also looked at metals and oxygen, which make us metal oxides, which form a basic solution. And we've also looked at nonmetals and oxygens or oxides, and we get an acidic solution. All right, so right now we're going to be dealing with organic compounds. Now, organic is really funny because we hear that word organic in the grocery store. Ooh, organic food is so great. Well, it is really good, but guess what? All food is organic because any organic compound contains the element carbon. Now, almost all of the organic compounds also almost always contain hydrogen as well. So inorganic compounds, so this is the opposite of organic, include all those that do not contain carbon, as well as a few exceptions, and this is important to look at here. Exceptions like oxides, so this would be carbon dioxide. We've also got carbon monoxide here. We also have carbonates, which are not organic, and we also have carbides, which are not organic as well. So anything with like a CO3 or a CO or CO2, they're not organic even though they do have carbon in them. Next, organic chemistry is the study of compounds that contain carbon. Organic compounds are everywhere. They make up all the living things. They make up a lot of medicines, plastics, fossil fuels, and a lot of foods as well. If you think you had margarine or butter, guess what? It's a organic compound. So you can tell if a compound is organic by looking at the chemical formula. It will always contain carbon. Always contain carbon. And usually hydrogen. Now notice that the carbon is always written first. So we have CH4, which is methane. And if we were to, this is a covalent compound, so we would have carbon tetrahydride. And we also have ethanol, which is CH3CH2OH, and it's an alcohol. And we also have caffeine, so if you had a Monster Energy drink or anything like that, you would have had C8H4N4O2, and that is caffeine. It's a stimulant, and it makes us a little bit more awake. So that's organic compounds. Now, a hydrocarbon is just like it sounds. It's an organic compound that contains only carbon and hydrogen. So you can always tell what these look like because we have things that only contain carbon and hydrogen. Now, the really cool part about all carbon or organic molecules is that carbon is really cool because carbon forms the backbone. Because carbon has 4 valence electrons, that means that it wants 4 other electrons to bond with. All right? So because of this, it can make really long chains, it can make cages, even rings, and the structural rings, and it can also sometimes form with just two bonds between 2 carbons, and it can also form triple bonds as well. So very, very interesting. And if you were Superman, you would take coal and crush it to get diamond, and diamond is just pure carbon. So hydrocarbons and other organic molecules can be illustrated in a few different ways. So right here we've got a C and a C, H, 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 and H. This is called the space-filling model. The larger atoms are the carbons and the smaller ones are the hydrogen. And we have C2H6, and the trade name for this is ethane. So we can write it, that's the space-filling model. They kind of look like little Play-Doh balls. And then we also have the stick and ball method, or stick and ball model of the same molecule. So we have our C, and we have our 3 H's on each C. And you'll notice that we also have C2H6, and each element is satisfied. The H's both have 2 electrons in their outer shell because they're sharing them, and the carbons both have 8 electrons in their outer shell. We can also draw in the form of a structural formula. Now, which is a simple way of drawing the arrangement of atoms. So what you'll see is we've got our C's in the middle, they form the backbone, and we've got H's all around. So really what's happening is we've got the Lewis diagram of this molecule would look like this. And they're all sharing so that they all have full shells. Pretty cool. Now, many hydrocarbons that we've talked about, hydrocarbons have C and H in them. They are flammable, meaning they burn. So propane, you find that in your barbecue and other appliances, it burns really, really well. So another type of organic compound is an alcohol. Now there's something special about this because not only does it contain carbon and hydrogen, it also contains oxygen, right? So there are many different types of alcohols, and some of them are very useful as solvents. So we can dissolve things. So if you think about paint thinner, guess what? It's an alcohol. It's an organic molecule because it can dissolve things like paint. So if you get some on your hands, you can use paint thinner. Now, a solvent is a liquid that can dissolve other substances as well. So what we have is here's some examples of organic and inorganic molecules. So remember that if we have a carbonate, it's not an organic molecule, it's inorganic. And we have CH3, CH2, and OH. Well, this is organic. And we can classify this as an alcohol because it's got an OH. And we've also got one down here, we've got CH3OH, and this is also organic because it only contains C's, H's, and O's, and it's also an alcohol. Alright, we're going to get more practice of this in class. Have a good rest of the day.